Okay, so in our last video, we actually did a simple example where we fit technetium hexachloride. We're going to continue on with that example, but we're going to show how we improve our error analysis. So in our GUI directory, let's type Python 3 EXAFS GUI.py, and we'll start up our program again. And we'll keep working with the technetium hexachloride data. So, oh, wrong folder. There we go. There's the data file. Now for the output, we're going to create a new folder called multi-run. And in here, we're going to run the program multiple times with different input parameters so we can probe more of parameter space. And then we're going to analyze all the output files to get a picture of what the best fit in all the parameter spaces. This takes longer than a single run, but it does give you better data. Alright, and we'll put output in that folder. And then we have to select our FEF data again. And again, it's already been calculated, so it doesn't redo the calculation. We don't really need to change anything in the populations. 100 generations is fine. For our paths, we have to use the paths, and we used 1, 4, and 5 for the last fit because we know those are fairly good for this one. Mutations don't need to change anything. We need to change the fitting region so it fits a better region, 3.5 to 12.5, and background K weight of 2. Can make my window bigger so I can see what I'm doing. There's our background and raw data, data in K space, data in R space. Now for outputs to do multiple runs, we have to come out here and we click to create multiple input files. Now when we're running on a supercomputer, we usually run 100. On a desktop or laptop machine, we usually run 10. We give it a wide range of populations, generations, and mutations, so we're not using the same file parameters for each one. And then we'll hit generate input files. But the first thing I want to do is open up our multi-run to watch what happens. So if I open up our multi-run folder and generate input files, I'm going to put them in the multi-run directory. And it populates these with 10 input files. We could go in and we could change parameters in the input files. You can actually make up these input files manually if you really want to. Once we have the number of input files we want, come back to the GUI and we can hit the Run Multiple Input Files button. And this will go and run through each one of these in sequence. So it prints out which files it's going to run, and then it launches the analysis package. And it's going to go through this over and over and over again. Now, because there's a wide range of populations, generations, and mutations, it can take much longer for each generation. So once you start one of these, it's usually a good idea to sit back, walk away, take a break for a little while, because this will almost certainly take a significant portion of time. So with the amount of population, generations, and mutations that we have here, it's taking almost 16 seconds for each generation to go through. So this is going to take a long time. So right now what I'm going to do is I'm going to pause the video and then I'll come back at the end. Okay, well, instead of waiting for that one to complete, switch to one that was already finished, where we had run 10 file inputs, and you can see we have output data 000, 001, 002, all the way out to 009. So now we come to the analysis window, just as we did for the last time. We choose the directory that all these output files are in, which is multi-run here. Select that, and now I run analysis again. Now it combines all of those output files to find out what the best overall fit was and what the error bars on the fitting were. So we can plot the data and the best fit with our genetic algorithm. In K-space and R-space, we can plot the individual K-space paths along with the raw data. We can plot the error as well. So printed in here as well as saved in the text file again is our table. We can select the table, copy it, and paste it into Overleaf or whatever LaTeX editor you want. Compile it. Oh, project has an error. There we go. And you can see our table. All we have to do is change the name of the table, but it has our paths, tells us about the paths, it tells us about our fitting values and the errors in our fitting parameters, and it requires everything necessary to report. Okay. Again, it has the plot that you can save from here if you like to use matplotlib, or also stored in the directory, the analysis directory, are the Igor profiles that you can load in and use that to make your publication quality graphs. So again, we recommend, because genetic algorithm uses deterministic randomness in order to find the data, that you really do want to run this multiple times for each spectrum that you're trying to analyze. You don't want to just run it one time. But again, you can run it, walk away, and then come back when it's done. So this is something that we really strongly recommend you do for all of your data.